Hi, in this video we're going to be looking over section 1.3, which is applications of linear equations. So in the very beginning of this section, we actually look at words that'll help clue us in which type of operation we're going to be using. So we've got words that are especially for addition, subtraction, multiplication, and division. So some words that go along with addition would be words like the sum, or more than, or things like plus, or greater than, or things like that. Subtraction, words that would go along with that would be things like minus, difference, less than, of course, subtract, that makes sense, decreased, so say decreased by. Addition, we could have increased by. Words that go along with multiplication would be things like the product of, or times, or words like twice, or 3 times, or triple. So if you say like twice the amount of this, then it means 2 times whatever that amount was. Words that go along with division would be things like the quotient. This is supposed to be a U, quotient. And then we've got words like per. So if you have like $10 per 5 games or something like that, that's $10 over 5 games. Or the ratio of. So we're going to go ahead and look at some expressions and translate them, in words, and translate them to symbols, so numbers and operations. If we saw something that said twice a number plus 5, well, the number that's unknown would be x. So twice a number plus 5 would be 2 times x plus 5. Or something that said 2 less than the quotient of a number and 3. Well, 2 less means that you're going to subtract 2 from whatever that is. And the quotient of a number and 3, well, the number, the unknown number, is x, and it's being divided by 3. So we've got x over 3 minus 2. I wrote those kind of far apart. So when you say the quotient of a number and blank, the first part is the numerator and the second part is the denominator. However, sometimes you might hear the numerator second and the denominator first. So if you said something like, 5 divided into a number, well, that would be the number divided into by 5. That's kind of a weird way of saying it though, but it's possible to see it that way. So hopefully that kind of makes sense, how you can throw these words into different phrases to write expressions. Sometimes it's a little more complicated, like the product of a number and the sum of that number and 17. So product means we're multiplying 2 things. So it's the product of a number, so that's just x, and the sum of that number and 17. So that number and 17, since it says sum, that means we're adding. So we'd be multiplying x times x plus 17. The next thing in this section is actually looking at distinguishing between simplifying expressions and solving equations. And we talked about this a little bit in class, about being able to tell when you're looking at an equation and when you're looking at an expression. And the goals of those 2 things are very different. And so it really comes down to, is there an equal sign, right? So if I give you 2 different things and we determine which one's an equation and which one's an expression, we know with the expression we're just simplifying what's there, and with an equation we're solving for the variable. So if I give you these 2 things, you should be able to tell which one is the equation and which one is the expression. So pause the video here and see if you get it right. So you should have said the one on the left is the expression and the one on the right is the equation. So we're going to work with the one on the left first. So what we're doing on the left is we're actually just simplifying what's there. So to simplify it, what I'm trying to do is I'm trying to combine all like terms. So in order to do that, I need to follow order of operations, which is parentheses. So simplify in the parentheses if you can. I can't really. And then exponents. Multiplication and division are the same importance level, so you just go left to right with those. And then addition and subtraction are the same importance level, so you go left to right with those as well. So here, since I can't simplify what's in the parentheses, then the next thing I'm going to do is multiplication, because there's no exponents. So if I distribute that 3, so I multiply that 3 by everything in the parentheses, then I'm going to have 3x minus 3 times 5 is 15. And I still have that plus 2x and the minus 1 after that. So from here, your like terms, you can go ahead and put next to each other. So the 3x and the 2x, since the negative is, or the minus is in front of the 15, make sure the minus stays with the 15. And then we're going to go ahead and combine our like terms. These two have x's with them, so they're like terms. 3x plus 2x is 5x. And negative 15 minus 1 is a negative 16. Now I'm going to use those a little bit interchangeably because plus and negative is the same as minus. So when you see a negative there, you can really treat it as a minus. Unless you're multiplying stuff, and then you just have to make sure it's a negative number times something else. Okay, but that is as simplified as we can make it because those two terms are not like terms, so we would have to stop there. So let's go ahead and look at the equation. Since this one has an equal sign, that's how we know that this one is an equation. So our goal for this is going to be to actually solve for x. Now a lot of the steps are going to be the same because the first thing you want to do is actually simplify both sides of the equation. There's nothing I can do with the right hand side, so that just stays the same. But on the left hand side, we're pretty much going to do what we just did. So distribute that 3, and we have 3x minus 15, and then plus 2x. And then combine like terms. So 3x plus 2x, and then I have that negative 15 still. So I end up with 5x minus 15 equals 1. And then the left-hand side is as simplified as I can possibly make it. So now I'm in the mode of trying to get x by itself. So I want to get the term by itself first. So I want to get rid of that minus 15. So I'm actually going to add 15 to both sides. So I get 5x equals 1 plus 15 is 16. And then to get the x by itself, to undo the multiplication, right, because 5 is multiplied by x, I have to divide. And when I do that, I end up with x equals 16/5. The thing is, we're not always going to be working with just straight up equations. Sometimes we're going to be working with word problems, which I know is everybody's favorite. But when we're working with word problems, there is a 6-step process that this book gives us to help us get through them. So the first step is pretty obvious. You want to read the problem, and it doesn't mean to just read the problem, but to comprehend what you're being asked for and to comprehend what information you're actually being given. So once you know what information you're being given, what you're actually being asked for, then you can assign variables to the type of information that you're being asked for, right? The unknowns. Assign variables to those, and you should say what those variables stand for. Number 3 is to write an equation. Number 4 is to solve it. With a word problem, you should always be able to state your answer in a sentence because if you just put a number, that doesn't mean anything. You need to be able to put units on it and actually say what that answer means. And then finally, number 6, you should always be able to check your answer and show that it ends up with a true statement, which remember we were talking about before means that both sides of the equation are equal to each other. Got a problem for us here. It says the length of a rectangle is 2 feet more than twice the width. The perimeter is 34 feet. Find the length and the width of the rectangle. So again, first part is just reading the problem. What are we being asked for? What information are we being given? We're working with a rectangle and we want to find the length and the width of it. If you can, it's always a good idea to draw a picture of what you're working with. Pretend that looks like oh my gosh. Pretend it looks like a rectangle, but we've got the length and the width here, right? So length, width. It says the length of the rectangle is is a good word for meaning equals. So the length is 2 more, which means you're going to have plus 2 at the end here, 2 more than twice the width. So is equal to 2w, so twice the width plus 2 more. So we've got the length, or an expression for the length, and the width. Since I did assign variables, I said that L was equal to the length and W is equal to the width. We also have an equation for perimeter. We did talk about this in class as well. So the perimeter is when you add all the sides together, so it's the distance around the outside. So that means the perimeter is equal to 2 times the length, and I want to get this in terms of one variable, so I'm going to have 2 times 2w plus 2 plus 2 times the width, so 2w. But we were actually told that the perimeter here was 34 feet. So instead of writing P, I can actually just write 34. And then it's a matter of trying to solve for W. So the left-hand side, that's already simplified. I don't need to do anything with that. But the right-hand side, I am going to have to simplify that quite a bit. So first of all, I'm going to go ahead and try to simplify in the parentheses. I can't. Those are not like terms. There's no exponents, so I can't do anything there. But I can multiply. So I'm going to distribute the 2. 2 times 2w is 4w, and then 2 times 2 is 4. And then I'm going to go ahead and add my like terms. So I've got 4w plus 2w, so I end up with 34 equals 6w plus 4. And then once I have simplified as much as I can on the right-hand side, which I did because those are not like terms anymore, I'm going to try to get the term with the w in it by itself. So I'm going to subtract 4 from both sides. 34 minus 4 is 30. And then to get the w by itself, well, it's multiplied by a 6. So to undo the multiplication, I'm going to divide by 6. 30 divided by 6 is 5, so I end up with 5 equals W, and I want to know L as well. And so remember, L was 2W plus 2. So L is going to be equal to 2 times 5 plus 2. So 10 plus 2, which is 12. And remember, I should be able to state my answer. So here we would say the rectangle has a width of 5 feet. Everything was in terms of feet, and a length of 12 feet. So there I've stated my answers and the units that go along with them. So the last part here is to actually check my answer. How do you do that? I'm going to let you guys take care of that because I'm running out of time here. But I'm going to stop this video here, and then I'm going to make another video with some more word problems. So I'll see you in just a second.